This is Daniel Coosbury, and in this video I've decided to show you a example I just recorded in one of the other normal distribution videos. But I'm going to show you instead how to find these probabilities using the TI 83 or 84 calculator, which I think you're going to like a lot better than using the table. So if you're interested in how to use the table to find the probabilities or the theory behind it, you need to watch the normal distribution video, but otherwise this will give you some shortcuts that I think are going to make your life easier. So I've got another normal distribution problem where, well, this is the same one. The Scottish militiamen are normally distributed. Their chest sizes are normally distributed with a mean of 39.83 and a standard deviation of 2.05. And I want to find the proportion of militiamen whose chest sizes are between 37 and 40. So I'm going to start by drawing the same picture, which regardless of whether I'm going to use the table or use my calculator, I draw this picture every time because I need to have some kind of idea what I'm trying to do. So I'm trying to find the area under this curve between 37 and 40, which is this area right here. So it's a little bit bigger than the mean and a lot less than the mean. And the reason I'm still having to draw this picture is because when I go into my calculator, there's a function that we're going to use that is really good at finding the area under the normal curve between two values. It's called normal CDF. And it takes 4 arguments. So if you've got an older calculator, you're going to need to type in 4 things separated by commas. If you got a newer calculator, it'll kind of tell you which one of the things are. But it's going to take a left boundary, and I'll show you what that means. It's going to take a right boundary. It's going to take a mean and a standard deviation, which frankly we're going to have a really easy time with this because that's the mean, that's the standard deviation for anything we're doing with this problem. So we're trying to find out the probability that X is going to be between 37 and 40. And if you've already watched the normal distribution video, you saw that I couldn't do this problem without converting it to a standard normal distribution first, and then using that table, because the table, there's only really one table and it's for standard normal. I can get around that now because I have a calculator that can find me normal probabilities using any mean and any standard deviation, which means I don't have to do any converting. Instead, I'm just going to use the normal CDF function. And let me show you just how nice this is to punch into your calculator. I'm going to do normal CDF. My left bound is going to be this left boundary of my shaded region, which is 37. So I want to find stuff no further left than 37. My right bound is going to be the right boundary of my shaded region, which is 40. See kind of where those numbers came from, 37 and 40. So I'm finding between those two things. They're my boundaries. My mean is 39.83, and my standard deviation is 2.05, and that'll give me my answer, which should match the answer, or it frankly will be a little more precise than the answer you get from using the table because your calculator is going to give you better more precise numbers. So I'm going to find normal CDF. Sorry, I did that fast. Normal CDF by doing second vars, going to the distribution section again. So second vars, and then I'm going to normal CDF's the second thing there. So there's normal CDF. I've got a newer calculator, which means instead of typing it like this on my screen, I've got some nicer things. I've got lower, upper, mu, and sigma. So I'm going to type in my lower, upper, mu, and sigma. If you've got an older calculator, you're going to need to type that on the home screen separated by commas, and it should work just fine. There should be a 3 there. That's a 3. Oops. 39.83 and 2.05. And I'm going to paste. So now let me show you, if you got the newer calculator, what's pasted on your home screen is exactly what the folks with 83s and older 84s are typing. So 34, 40, 39.83, 2.05. I'm going to hit enter, and there's my answer, 0.4493, which is a little more precise than our answer. But on the other video, our answer was basically the same thing, 0.4493. So I'm saying a little under 45% of the data of the distributions between those two numbers. So that's really nice. The normal CDF function is really nice because you tell it two things to look between, and the mean and the standard deviation, it'll tell you the probability very quickly. That happened very quickly. And I think it's a much cleaner way than using the table, frankly, even though the table is fairly classic and well used and accurate. So now I'm going to show you how to do the rest of these problems using your calculator. They're not all quite as straightforward as you've seen. It's a really nice function if you're looking between things. If you're not looking between things, you got to be a little more careful in what you type. So here's my distribution again. I want to find the proportion of militiamen whose chest sizes are less than 35, which means I'm going to find this blue shaded region. And I'm doing the probability that X is less than 35. And I've already kind of got a problem here because I'm going to do normal CDF now. And this begs the question, okay, well, what's my left bound if I'm looking for everything less than this number? So I'm going to think everything all the way over here, this goes on forever, and it comes all the way up. My right bound is going to be 35. But what should my left bound be? Well, frankly, with any normal distribution, technically this goes on forever. Like it goes all the way to negative infinity, a huge negative number. So technically speaking, like that area goes all the way to the negative infinity. Now we can get away with just typing a big negative value here to represent negative infinity. Not the same thing, but I like to just do that. I like to just pick a bunch of nines, put a negative in front of it. That's a huge negative number, and that represents my left boundary, that I'm going all the way to negative infinity. Again, they're not the same thing, but that's the best I can do. And you can go bigger, you can add more nines, but that's the best you can do. The right boundary is going to be 35. The mean is 39.83, and the standard deviation is 2.05. You put in your calculator just like that, you'll get a nice answer. So I'll do the normal CDF thing again. So my lower bound is going to be negative 99999. You can keep hitting nines if you want to. Upper bound is 35. My mean is the same. My standard deviation is the same. So that's what you type on your home screen if you got the older calculator. Start with a 99999, negative 99999. And I get 0.0092, which is a little different than what we get from the table. And that's just because the calculator is going to be more precise than the table. It's going to be even more precise if you add more nines to that. So, but this is my answer. This is what I would report, 0.0092 as my answer. So the reason I'm showing you how to do all these problems again is because when you're searching between two numbers, these two endpoints are obvious. When you're not doing between numbers, you got to use some big numbers for one of your endpoints. So let me show you another one. We're going to find the probability that a chest size is 42 or greater. I'm sorry, that should be the mean. So this is 39.83. I'm trying to find up to 42 or greater. So now I'm doing a greater than problem. You remember with the table, I had to do the 1 minus trick every time I saw greater than. This is going to be much easier to do because I've got the normal CDF function, which gives me a left boundary, which my left bound will be 42. My right bound will be, well, this goes all the way to positive infinity. So how about I just pick some huge number like 99999999999 or something, and I'll do 0.83 and 2.05 as my my mean and standard deviation. So this is, notice this is a little bit opposite what I did when I'm doing less than. Huge negative number, and then the right boundary came here. I'm doing greater than. You can see how the picture kind of helps. This is my left boundary. That came from here. And my right boundary is a huge positive number. So the reason I keep drawing the pictures is because I would get the left bound and the right bound confused if I didn't have the pictures. But with the pictures, I can tell the calculator this is the left, this is the right, this is, or I think they call it the upper bound. This is the upper bound, that's the lower bound, mean and standard deviation. And I can put all that in the calculator just like that and get a nice answer. So my normal CDF, my left bound's 42, my upper bound is 99999999999. I think I put, and then that's the same, that's the same. I get 0.1449 as my answer. I'm sorry, that should be a 4. 1449. And that represents this area right here. So you can see that it's a lot quicker to use your calculator, and it's one of the reasons we're using these calculators. And for the less than, greater than, and the in between, you've got like sort of 3 different methods. But really, I think if you have the picture, then your left bounds and your right bound should be obvious. This is lower, upper in the calculator. So like if you have the picture, you know this goes to negative infinity to 35. That left and right bound's obvious. You know this goes from 42 all the way to positive infinity. The left and right bounds are obvious. I want to show you another function that will give you the percentile in the calculator. So here is my normal distribution still. And you're doing an 80th percentile, which means this part is going to be 80%. The part to the right of this is going to be 20%. And so I want to find what is the number on this number line. Why does this 3 never write? The number on the number line that gives me the 80th percentile. So we're going to just remember that the percentiles are the numbers on the number line, and the probabilities or the proportions or probabilities are the area under the curve. It's just important to keep those things straight. Otherwise, you're going to do these problems wrong. So the area under curve is equal to probabilities or the proportions. Same kind of, different question, same kind of method. The number on the number line is going to be the percentiles or the z-scores or the means or things like that. But these numbers are different than these decimals up here. And I've got the normal CDF that will give me the area under the curve. And I'm going to use a function called inverse norm to give me numbers on the number line. Okay, so there's 2 things to keep straight now. I've got one calculator function that'll give me probabilities and proportions that we just used 3 times. This calculator function will give me things on the number line, so like things like P80 or z-scores or something. The way this function works is you tell it first what's the area to the left of the number on the number line. And then all you got to do is tell it the mean and the standard deviation, and it'll tell you what number should go here. So for this problem, I'm interested in the area, whatever this number is, I don't know what it is. The area to the left of this is 80%, 0.8. So all I've got to do is I've got to tell the calculator 0.8 is my area to the left, tell it the mean and the standard deviation, and you can find the P80, the percentile, if you want to. So my area to the left is 0.8. My mean is 39.83. My standard deviation is 2.05. And I'm going to go in my calculator now and show you where that is. Inverse norm is actually in the same place. Second bars will get you there. Distribution. It's the 3rd thing there. You got the newer calculators. You can tell it the area to the left, the mean and the standard deviation. So my area to the left is 0.8. My mean is 39.83. And my standard deviation is 2.05. And there's your answer, 41.56. This is actually more precise than the way we got it from the table. The table, we had to go find where 0.8 was and then convert the z-score, and it was a little less accurate because we couldn't always find on the table where 0.8 really is. In fact, I think I have it here. We looked on the table for 0.8 and we couldn't really find it, so we settled for something that was 0.7995, which wasn't quite right. So using the calculator will give you something much more accurate because it has mathematical methods to get you there. So there's how to do that. There should be a 3 here still. Man, that's not writing. But this is how you do it. So this P80 is now, we can now write down a value for it. This number on the number line, we're not sure what it is 41.56. It separates the lower 80% from the upper 5% or 20%. All right, let me do one more for you just to show you. It doesn't really matter what the percentile is. We can find it. So this is 39.83. I want to find the 34th percentile, which is over here. It separates the lower 34% from the upper 66%. And this is P34. So I'm going to do inverse norm. My area to the left is now 0.34. See that? So there's the number. My area to the left is 0.34. The mean is 39.83. Standard deviation is 2.05. I can do that in the calculator. So I'm going to go to second vars, inverse norm, and do 0.34. Keep the mean and the standard deviation the same. And I've got 38.98 as my answer. 38.98, so almost 39. So that number down here then is going to be 38.98. So that's how you do these problems with the calculator. There's two functions, and they work kind of in opposite ways. So the normal CDF will give you areas under the curve. Inverse norm will tell you things on the number line. And that should be enough to get you to do pretty much any normal distribution problem, including standard normal problems, which I didn't have an example of here. But if you're dealing with standard normal, just remember that your mean is equal to 0 and your sigma is equal to 1, which means you're doing normal CDF. You've got your lower bound, your upper bound, your mean, and your sigma. Then whenever you're doing stuff with standard normal, just do it like that. Just put your lower and upper bound, there's your mean, there's your standard deviation. If you're doing inverse norm, you've got your area to the left, you've got your mean and your standard deviation. Then your mean and standard deviation are that, and you've just got to tell it the area to the left. So in other words, when you're in standard normal land, these are the only things that you have to decide, these three things. The rest of them, the mean and the standard deviation are already decided. So this works for standard normal distribution too.